let's look at some examples involving the average value of a function. So for this first example, suppose we want to find the numbers b such that the average value of the function f of x equals 2 plus 6x minus 3x squared on the interval from 0 to b is equal to 3. So what I want to do here is consider the formula that we have for the average value. So we know that the average value of function f is 1 over the length of the interval. So in this case, b minus 0. And we're integrating from 0 to b the function f of x, which is 2 plus 6x minus 3x squared. So in this case, one thing I want to point out right away is that notice that it's not possible for b to be 0. We'd be dividing by 0. We can see that the integral would evaluate to 0. So we can safely assume that b is not going to be 0. My antiderivative here, what I want to think about is, first of all, I have 1 over b out front, and we're going to have 2x plus 3x squared, minus x cubed. And we're evaluating that from 0 to b. So when we plug in our endpoints, we still have this 1 over b, and I'm going to have 2b plus 3b squared minus b cubed. And so when I divide by b, that's going to leave me with 2 plus 3b minus b squared. So what we want to consider here is if we are setting this equal to 3, so 3 is equal to 2 plus 3b squared, 3b minus b squared. So again, that's because we want the average value to equal 3. Then this is the same thing as wanting to find where b squared minus 3b plus 1 is equal to 0. So that's not going to factor nicely. So let's think about using the quadratic equation. So we've got here b equals, now let's see my coefficients, 3 plus or minus the square root of 3 squared, so 9, minus 4 times 1 times 1, and this is all over 2 times 1. So this becomes 3 plus or minus, let's see, 9 is the square root of 5, all divided by 2. So we see here that there are actually going to be 2 different values of b that would work. And of course, we could go back and check this to see that the average value that we get ends up being 3. So that's one of our examples. Down here, I've written another one. So let's, just get ready, I'm going to need another sheet. So we're going to have the function 1 over x, and we are here having this interval from -4 to -2. But we want to find the value c within that interval such that the function f of c is equal to the average value of the function f of x over, sorry, this should be a -2, so that interval from -4 to -2. So again, let's think about our average value function here. We're going to take 1 over the length of the interval, which in this case the length of the interval is 2, -2 minus a -4, and we're going to integrate from -4 to -2. The function's 1 over x. So here you want to be careful and remember that the integral gives the natural log of the absolute value of x, which is important when evaluating this here. And so this leaves me with 1/2 natural log of 2 minus the natural log of 4. And for this, it's going to be a little bit easier to try to condense this. So if I think about my log properties, so first of all, remember that log of 4, right, I can think of this as the log of 2 squared. And with log properties, I can bring that exponent out. So this is -2 log 2. So from that, I can see that this is the same thing as -1/2 log 2. And further, then that's the same thing as the natural log of 1 over square root of 2. So that's because I can, again, bring this back in as an exponent, and 2 raised to the minus 1/2 is 1 over square root of 2. So that's the average value of f over this interval. The problem wants us to find a value c. So here we want f of c to evaluate to that average value. And that means that if we think of f of c, we need 1 over c, because that's what the function gives us. We need that to equal this natural log. And therefore, if I'm solving for c, we need that to be 1 over the natural log of 1 over root 2.